Okay, we're going to take a look at inequalities involving absolute value, section 5.5. And we've got some kitty cats that I have. One is Faith and one is Jasper. Just thought you'd like to see a couple of kitty cats. So we're going to deal with one example in this video, and then I will cover the second example in another video. So the first one is we're dealing with the absolute value of x being less than a number. In this case, 2x minus 5, the absolute value of that is less than 7. What we're saying here is because absolute value refers to the distance something is away from 0, we're saying that 2x minus 5 is less than 7 units away from 0. And so we illustrate that with a number line. And so we have two boundaries because both of these are exactly 7 away from 0. And so we establish those boundaries, and then we say, well, the 2x minus 5 has to be less than 7 away from 0, so that's going to put it in between this negative 7 and 7. Those are all the values that are actually less than 7 away from 0. And then, so that's what 2x minus 5 is going to be. So, when we look at this, it's very easy then to write our inequality because you can use the graph to write the inequality. What we're going to do here is we're going to start at the boundary, and we're going to compare the boundary with the 2x minus 5. Well, the boundary is on the left side of 2x minus 5, so it's smaller. It's less than 2x minus 5. So negative 7 is less than 2x minus 5. But how does 2x minus 5 relate to the other boundary? Well, that is also on the left side of this boundary, and so it is less than 7. So there you have it. Negative 7 is less than 2x minus 5, which is less than 7. And so there you have it. So now we're going to solve and get x by itself in the middle. And so we have to get rid of the negative 5 and then the 2. So we get rid of the negative 5 by adding 5 to all three sides. And then we have 2x by itself. So now we're going to divide all three sides by 2. And so that gives us negative 1 is less than x, which is less than 6. Well, in a sense, we're done. That is the solution, is we're saying that x is between negative 1 and 6. Now we illustrate that by a graph, and so we put our boundaries in again. So we have the left boundary is negative 1, the right boundary is 6. X is going to be all the values in between. And there's our green line, and so x is represented by all the values that are in the green section. So this is called an AND, is when you have, and you notice that this is going to be when the absolute value of something is less than, then it's going to have this pattern. It's going to be referred to as AND. So we have 2x minus 5 is greater than negative 7, and 2x minus 5 is less than 7. It's going to fulfill both of those. It's also an intersection between two inequalities. It's where they're common, just like the intersection of streets. And then we also use the word between for this. So less than with an absolute value means we're going to have something that's where it's going to be between two boundaries. And so we want to check the answers here, so make sure our answer is correct. So we have the original equation over here, and then we have our answer. And we're going to check the solutions, or what we say are the solutions, into the original. And so as we look at the graph down here, we want to pick something here that's going to be not one of the values that are part of the solution, and to see if that actually makes this inequality false, which is what it should do. And so we're going to do that with -2 first. So we substitute the x with -2. And so you have -4 minus 5, which is -9. The absolute value of -9 is a +9. Is 9 less than 7? Well, no. And that's exactly what we wanted to see happen. Now we're going to go over here on the other side and pick a number here that is also not on the green, and that should also make that inequality false. And so we check out 7. And so we get 14 minus 5, which is, that's also, that actually should be 9, not -9. And so the absolute value of 9 is 9. And is 9 less than 7? No. And so that works out again. Now we're going to pick a value, and we could pick any value in here that is on the green. And we're going to go ahead and pick the 0. We're going to see if that makes this inequality true. And so we substitute that in, and we have 0 minus 5. And then the absolute value of -5 is 5. And is 5 less than 7? Yes, it is. And so, therefore, we have seen an example that makes the original inequality true, and that verifies our answer of -1 is less than x is less than 6.